The second important effect due to nonlinearity that we want to see is called as gain compression. What do we mean by gain compression? It happens because transistors go into saturation at higher input power levels. If you have at a certain frequency, let's say the operating frequency of the amplifier, you have a certain input, then the output of the amplifier is plotted here. If it had been a linear amplifier in an ideal world, if the input power increases, the output power increases accordingly by a factor of the gain of the amplifier, which we call as G naught. That means for a certain input, I have a certain output. If I increase the input, then the output also increases correspondingly. But does this happen all the time? If I keep on increasing the input like crazy, let's say instead of 1 watt, I go and make it as 10,000 watts. Will the output be 10 times 10,000 watts? The answer is no, because the real situation that you see here is in red. You're going to compromise the gain beyond a certain input point, and turns out that you want to define that input point where you're compromising the gain as P in 1 dB. What does that 1 dB mean? Is the amount of gain that you have compromised. If the transistor had been ideal, you would have got a gain of this much. That means the output would have been this much. This would have been the output level of the transistor had it been ideal. But because you have compromised the gain by 1 dB, you're falling short by a factor of 1 dB. And 1 dB is taken as a standard. Beyond that, the output signal is going to be more distorted. You can tolerate up to a compromising point of 1 dB. Beyond that, you don't want to compromise. So that means you can operate this transistor up until this input power level. You should not use this amplifier beyond this input power level, because otherwise the gain is going to be hugely compromised. You're going to create other kinds of harmonic distortions coming in. So corresponding to that input 1 dB is your output 1 dB. So clearly, P output 1 dB is going to be, this P out 1 dB is going to be actually, for an ideal transistor, it would have been P in 1 dB plus the transistor gain, So this could be in dBm, this could be in dBm, and this is in dB. But then this is not ideal anymore, right? So you're compromising 1 dB of gain. That means I have to subtract off 1 dB here. So this P out 1 dB is P in plus G minus 1, the 1 dB that you're compromising. That is called as a 1 dB compression point. The another important parameter that you see here is what is called as this DR, which is called as the dynamic range. What do we mean by dynamic range? That means the range of power levels that can be tolerated or can be used, this amplifier can be used in. The upper limit is very clear, it is a P in 1 dB. So dynamic range is how much of the output power you can achieve from this transistor. So you're looking at the output. The upper limit is pretty clear, is output P out 1 dB. How about the minimum level? You want to know what is the minimum detectable signal. MDS is the minimum detectable signal that is useful. That is the minimum detectable signal that is useful that comes out of the transistor or amplifier. So this range is what is usable range of this amplifier. Above that, it's not useful because you're compromising the gain too much. Below that, it's not going to be useful because the signal is not detectable. Typically, the minimum detectable signal is 3 dB above the noise power. That means the lowest signal that you can receive is typically 3 dB above the noise power. That means the signal is having at least 2 times the power of the noise, so that the signal can be heard, not lost under noise. The dynamic range, both in terms of the output, which is the P1 dB, output 1 dB minus output MDS, or you can define it in terms of the input, where the 1 dB compression points minus 1 has to be factored in. So it's essentially You can either define it this way or by the factor of this minus the 1 dB that you see for the compromising in the gain of the amplifier. So that's gain compression.